Here we go. Yay. All right. Well, welcome everybody once again to Astronomy Daily Live. Got the little critter here on the lap, so all must be well. So hope everybody's doing well. Just noticing that Bobby is gonna pop onto the panel here. Hey there, Bobby. What's going on?
Come on, RT, what are you doing?
Haha. we are live.
Yeah,
So
I'm having
hey,
a little bit of trouble here.
yeah, some technicalities. All right, well, you'll work it out. No worries. No worries. We'll just sit back and enjoy watching our tails move and stuff. Yeah. All right, so hope everybody's doing well out there in the universe and the world.
Okay, hey guys, how you guys are doing today?
Yeah, things are good. Things are good. Just a nice.
I don't know what's going on with this update of Chrome OS 72, but it's really making me mad. I am not.
Well, hopefully you'll be able to work it out. We're just here chilling tonight. Kitty on the lap, so things can't be all that bad. Yeah, so let me open up the chat here, make sure that that is up and running. Yeah, cool. All right. Well, so hope everybody's doing well. Yeah, it's still cloudy here. It's it's been actually cloudy quite a bit. So it's kind of an unusual season here. It's usually pretty clear here in the desert Southwest, but recently it's been cloudy and wet. In fact, I think it's supposed to be. It might even be raining as we speak. So I don't know what's going on with all that weird wet stuff that just somehow just falls out of the sky. Hey there, Twin Crow. Nice to see you. Nice to see you in the chat. Cheers. So yeah, so this is just a friendly, fun gathering of friends each and every day, or almost every day, to come together and think things. Lots of astronomical topics, lots of science, lots of nerdy things, that kind of stuff. Hey, Bobby, could you turn that down just a little tiny bit?
I can turn it off if that's what you want.
Well, I don't want to necessarily interfere with your listening, but it is a little tiny bit loud on this end. So that'll be cool. All right, cool. Excelente. So,
and I got a little crip on the neck as well.
Wow, you're just having lots of troubles today.
Yeah.
Well, all right. Well, cool. Well, as I said, everything is good here. If you've been following my Discord server, you've noticed that I put a few plots up. Hey there, Tom. Nice to see you in the chat. Cheers. So yeah, everybody grab your favorite consumable of choice. Mine is the hydrogen hydroxide again, HOH. Here, so cheers. Cheers to that.
Hey, Twin Crow.
Good stuff. Good stuff. Yeah, Twin Crow is in the house. Very cool. Nice to see you there. But yeah, so I've been posting some plots of the data that I collected the other night, and yeah, it looks pretty good. It's a little noisy, but I can deal with those kinds of things. But yeah, it's some pretty interesting curves. This is Well, I can just pop over to the Discord channel, and we can take a quick
And
look
while
over
you do
there.
that, I just want to let you know that if you missed last weekend's opportunity to capture the ISS SSTB with your scanner or your favorite receiver, you will have another chance to do it again this weekend.
Cool. Nice. Well, that of course you depends on where you are on the planet too. I mean, your location might be good for that, Bobby, but not everybody's is going to be like that. But yeah, it does tend to repeat on some kind of a frequency. So yeah. The a good place to look out for those kinds of things is a website called Heavens Above, heavens-above.com, and you can you don't even
And
have
I
to.
forgot another one that might be good. It's called N2YO. Have you ever heard of that before?
I think I have. Yeah. There's actually even another site that will tell you when the space station is going to pass in front of the moon or pass in front of the sun. Right at your location too. Now, those events only last maybe about a second or so, right? They just zoom right by, because the apparent size of the sun and moon is pretty small, and the apparent motion of the space station is pretty fast, right? So I mean, it goes by really, really fast. But if you're at the right place at the right time, you can definitely see it. That's actually one of the things on my list. I definitely want to see that. Yeah. Maybe.
If you followed Martin, yeah, he's pretty darn good. He captured a satellite before.
Who was that?
Marty Titanio?
Oh yeah, of course, yeah.
How the bloody devil are you, Tim Robinson?
Hey there, Tim Robinson. What's going on over there?
All is good here. Thank you very much. Hope all you guys are good.
You're awake?
Yeah, only just.
Well, hang in there. It's good to see you over here for a little while at least. Yeah,
you
cool.
Too.
Yeah, I should probably look into seeing when the space station does pass in front of the moon here at my location. That might be something fun to look out for. So yeah, let me see if I can coordinate that.
I think a good. I'm not sure it's like for you, but it will tell you about when it's going to pass at your area. I use a program called gpredict, and I think it's available through your main package repository on Fedora as well.
Yeah. I usually use the website called Heavens Above, which is pretty good about those things.
Do you have the app as well for Heavens Above, or no?
I don't think I do. No, I just have the website. But the app
would be better off and stuff.
App would work too. So yeah, it's nice to have choices.
Hey, sure. Andy.
Hey there, Andy. Nice to see you in the chat as well. But yeah, I could try to find out when that pass is going to happen here, and we'd actually be able to watch it in that telescope. So So yeah, let me look into that. And
Excuse me, sorry, I entered a little bit late. What's passing?
Oh no, we were just talking about the possibility of watching the space station pass in front of the moon.
Oh, right, I see.
Yeah.
And the fact that this weekend there's going to be another AR ISS slow scan television event.
Cool.
Yeah, very, very cool.
I've seen the ISS pass over me twice. Yeah, twice. Yeah,
your latitude there, Tim, is just about as high as it's going to get. So yeah, your chances of actually seeing it are not quite as often as down here. Say, it really depends on your latitude. So I think you're up. Wow, you're probably up around what, plus 50-ish or so, or maybe not quite that much.
Couldn't tell you on that one, but I do know that I saw it pretty high in the sky. It was south. Bear with me. It was it was southwest, and it was quite high in the sky. Saw it again 90 minutes later, and I think a couple of days later I saw it again.
Very cool. Very cool. Yeah. Well, the orbit is 90 minutes long, so yeah. But to be able to see that twice in the same night, that is pretty cool. You know, things have to be just lined up just so, right, in order to do that. Yeah. But
it was a different path on the second passing that same night. Obviously, further that way.
Yeah.
I'm going like that way, as if you know which way I'm pointing.
That way.
Which way did he go, George? Which way did he go, George?
Oh my God. All right. Well, cool. So yeah, I'll try to find out when that's going to be happening here, and then maybe I'll drag this scope out. I'll put the webcam on it, and we can watch it. I mean, like I said, it lasts about a second or so, right? It's just like, phew, and that's it. So you got to keep your eyes peeled, and I would record it, right? And then we'd be able to play it back and all that slower and all that, but that might be a little bit of fun, to do that at least. All right, I got to reposition myself here, kitty. There we go. I'm sorry that I have to bother you. So sorry. Well, here she comes. All right. Anyway, so cool. Yeah.
That Twitch streamer Sets Meowth ever come up with a schedule yet?
Check me out. She, as far as I know, she is streaming on Sundays, but I don't know if she has any set schedule yet. So what'd you think of that, Bobby? Did you like that?
Oh, I love it with those singing bows, those wind chimes.
Yeah.
And what, I forgot what was that drum again, but that was a good one.
Yeah, it was just a metal drum. It's this metal drum that has cut in it these
that turned into a cat.
And it turns into a cat. Yeah, right here. Look at that big ugly face. She wants to play with my pen. So that's what she's after.
Oh my gosh.
Hello there, dear.
Okay.
Yeah. Well, I really like Check Me Out too. She's actually in school right now to become a sound therapist. And which I think is pretty interesting. I didn't realize that was like a profession, right? But it's kind of interesting. And
sound therapy. I heard like sound therapy. I think you can find a heck of a lot of sound therapy music and videos on YouTube for sure.
Yeah, yeah, and we're actually talking a little bit and seeing if I can make some of those sounds for her. But yeah, I mean, she sort of has her sound covered and all
Yeah,
that. I
so
mean,
thank
you know, she
you
does
for
really well.
that. Thank you for that information, Uncle Bill, about Sesame Out.
Mm-hmm. Yep. Yeah. Yeah. Anyway, yeah, I like her too. You know, I don't know if this is sort of a recent uh, fad or anything, but there's this what's it called, ASMR, um, and I'm absolutely not interested in that at all. It seems like a lot of people like it. I don't really. I mean, I don't really understand what the appeal is. You know, I mean, but to each his own, right? I mean, you know, whatever. But it's not exactly what she's doing. She's sort of taking a different approach, um, and not really following, you know, the ASMR uh, path. She's just making really, really, really great sounds, right?
And
And
hey,
she's
Tim, just want to let you know that's like an 8 on that sneeze.
So what?
Was that a sneeze?
No, I coughed.
Oh, okay.
Oh, okay, okay,
All
okay.
right. Yeah, I didn't
No,
think so. I didn't think
I'm not
so.
blowing the roof off tonight.
No,
I had a
see,
sneezing fit earlier.
we definitely judge sneezes around here, though. If you ever, you know, feel the need, you know, give us a good one, and you know, we'll give you a score. Because
Can you score me a 10 out of 10 if I blow Bobby's headphones off?
well,
my
you know,
God.
it's 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 not necessarily about the volume, though, right? It's the quality. It's the quality. It's the heart, right? It's it's those little subtle things, right, that make it great. So yeah, you know, when you're so inclined, give us a good one, and you know, we'll sort of score it here and see how you do.
Now,
And
out of curiosity, in the history of you going through gas stations, what is like the pretty much the most recent or the onlyest time you would have like a chemical spill? There's a chemical spill at the gas station.
um, those don't happen very often, at least around here.
I don't know, because like I went to I went to the gas station to like
Yeah.
get something for my people, and they said they got like a chemical spill that just happened before they opened up at around 5 o'clock in the morning.
Oh wow. Yeah. Yeah.
And and I remember at schools that all y'all wonder about is the pigeon running throughout the hallways at the front of the school inside. But what happens if you do got bats at a local school? Know what know like what Franklin did at the junior high? They had no choice but to evacuate that school and had to cancel school as well for tomorrow for sure
Because of a bat?
because of a swarm of bats.
Oh, so what? They're not going to hurt anything. They're just, you know, mice with wings. No problem.
Yeah.
No problem.
And
Oh well. Oh
I
well.
wonder worry when we get cats with wings.
Yeah. What do you think about that, huh? What do you
Flying
think
cats.
about cats with wings? Yeah. All right. Well, cool. So So yeah, I posted a couple, or I have been posting a couple of plots from my data that I took or the other night of the eclipsing binary star XZ Canis Minoris, and it's pretty cool. I caught it. I definitely did. And actually, the prediction is pretty close to what the data is showing, or I guess the other way around. The data is showing, pretty close to the prediction. What's that, Tim? What's that, Tim? I can't hear you.
Oh, shit. Sorry, I forgot. I should have muted.
Oh, all right. Sorry about that.
Pardon me.
No worries. All right, so I'm going to go over to my Discord.
If the cat lets you.
Yeah, I've got to look around her. Okay, she's now decided to go back onto the lap. All right, that's probably a better place. And let's see, I'm going to go over to the Discord here. And okay, so I'm ready. So let's go over there really, really quick. I don't want to spend too much time on this, but I do like to show off these little things. So there it is. So we'll blow this up here a little bit, and I'll show you what I've got. So along this axis, which I know that you can't see incredibly well, is the UT time, right? So 2:33, 3:34, right? 4:35, right? And along this axis is the magnitude, is the actual brightness of this star. And as you can see, this is about when I started, and it got fainter and fainter and fainter and fainter until about 3 hours UTC, maybe a little bit before that, kind of hard to tell. And then reached a bottom, and then it started getting brighter and brighter and brighter. There's an interesting little shoulder here, right? It sort of changes slopes, right? It is going up like this, but then it slowly kind of curves over this way. And I ended this just before 5 hours UTC, as you can see here. And at least according to this data, right, it doesn't look like it was quite finished yet. Not quite. So yeah. So I don't know if this is a real thing or not yet. This is all sort of preliminary, just sort of a quick look kind of a thing, but I think it's relatively accurate. But yeah, I mean, like I said, it was already sort of midway through coming down when I started. And we can actually go over to the predictions here. Let's see, this one, I think. Let's go over here, and we can look at. So according to this chart, or this table, I'm going to zoom in a little bit here so you all can see it a little bit better. So this is the one here, right? It was supposed to start at 1:26 UTC. Midpoint was supposed to be at 2:58, and then it was supposed to end at 4:29, right? So if you look at my plot, you can see that, yes, indeed, it seems to be bottoming out just before 3 hours UTC, right? Maybe right at it. It's kind of hard to tell. You know, the data is moderately noisy. I can't complain much, but you know, there are ways, you know, to clean this up a little bit. So it looks like the midpoint, right, is around 3 hours UTC, and that's exactly what was predicted. 258, right? So pretty good. But then, you know, it says that it was supposed to end at 429. Now, I guess I sort of have to understand a little bit more as to what they mean by ending, right? Because I mean, it is going, you know, to tail off, but I would think that the end is when it reaches its brightest magnitude again, right? It's bright, and then it gets faint, and then it re-brightens again. And this says 429, and if you look at the plot, right, and we move over to 4.5, which is 430.
I don't know how to say hello in Portuguese, but we got Ingrid in the chat.
Oh, hey there, Ingrid. Nice to see you. So we're looking at some data that that I collected the other night of a eclipsing binary star called XZ Canis Minoris. And so see, at 430 is when it was, you know, predicted to be at the end, but it looks like it's still brightening. It's starting to flatten out, right? It sort of looks like it is here.
Hola, Ingrid.
Hola, hola. So in Portuguese, that's the same.
Portuguese is the same as Spanish.
Well, at least in that case, it is. Yeah. Cool.
Mi casa.
And don't get me wrong, if you ever met her daughter from Spain, I think Tim learned a lot of Spanish from her.
Cool. But yeah, the other interesting thing that I noticed is this. It's like a little shoulder here, right? See how this is coming up, sort of like that. But right at this point, it sort of starts to smooth out a little bit. So yeah, not quite sure what's going on there. This seems really sharp too, right? I mean, it's not a gradual thing. We can actually go over to the AVSO site and look at some other people's data for the same object here, and let's go do that. Come on, you can do it. I know you can.
Oh my gosh.
So let's see. XZ CMI is XZ Canis Minoris, and then we can come down here and select a AVSO light curve, which I know that you can't see really well, but and then we got to hit go, and what pops up is some plots, right? So these are now in Julian days. Oh, and actually, there's a new observation over here that just happened. So actually, let's take a look at that. This was from yesterday, right? So let's take a look at that one. So I'm going to use the little zoom tool here to zoom in on it, and we'll see what this looks like. So this is someone else's data, not mine. We'll just zoom in and see. So there is someone else's, and yeah, see, I mean, mine seems a lot sharper, right? if you sort of look at this, right, that's a much sharper bottom than that. I mean, it's kind of hard to tell you because the scaling isn't exactly right. But let's see. They're going from about...
And I guess in your CCD camera, there's probably like no way for sure that you'll be able to like get rid of that noise. But what if you use your webcam? Would that be better off, or what's your preference?
Which camera?
I mean, can you eliminate the noise factor in your CCD camera, or would it be better off if you was like recording a video off of your webcam?
The webcam would be much noisier. Much noisier. Yeah, yeah. So, yeah, I'm not exactly sure how this data is being processed. Probably there's slightly longer exposures, which helps the signal to noise, which means less noise. So yeah,
Okay.
I'd have to investigate exactly how this data is being collected, but there's a little bit of a shoulder here, I guess, right? A little bit, so that's not bad. But they're going from about...
So longer exposures, you could actually deviate that noise and give you like a better chance of getting data, right?
Yeah, the problem that I have with longer exposures is that my telescope tracking isn't all that great. So I'm sort of limited in terms of the length of the exposure I can take. 2 seconds, maybe 3 seconds if the tracking is good, but that's about it. So I'm kind of limited there. And again, I'm not exactly sure how this data is being processed. So this could be an average kind of a thing, which definitely helps. You can sort of see here, I made an example here, how the averaging actually takes it from pretty noisy to pretty clean, right? So if this person is doing any kind of averaging or anything, then you're going to get a smoother curve. So yeah, but looks pretty good. They're seeing a dip all the way down to magnitude almost 10.7, and at least according to this, I'm getting down to maybe 10.6, maybe. So, but as I said, this is sort of preliminary. I wouldn't necessarily publish this yet because I'm not completely convinced that it's okay yet. These guys obviously are, and so they publish their stuff. But yeah, so this was taken right after mine, right? This was taken on the 13th at 2039, and if we look at the ephemeris here, that's this one, right? So here was mine, right? And here's this one. So just a couple orbits later, they did exactly the same thing. And
how old is your CCD camera?
how old is it?
Yeah.
It's pretty old. It's pretty old.
Do you think if you ever were off to get a CMOS or DSLR camera, would it will actually help you with your telescope with longer exposures and better technology, or what do you think?
Well, CMOS and DSLR are much noisier than CCD at this point. So I would never do that, ever. Yeah, no, I mean, when I make, any kind of upgrade, it is definitely going to be CCD again. So yeah, for sure.
DSLR was noisier.
For sure. Yeah. Oh yeah. Yeah. They're all much noisier than CCD at this point. Yeah. I mean, those things are getting better all the time, though. All the time. So I think in a couple years, they're probably going to be pretty close to the same, right? But at this point, CCDs are still the winners, for sure. It's kind of interesting too.
You get CCD cameras today?
What's that?
Can you still get CCD cameras today?
Oh, of course. Yeah. Of course. Yeah.
You can even buy
with,
cameras to put on a drone for FPV footage.
Yeah. Yeah. Absolutely. Absolutely.
So, like, what would you expect in your new CCD camera, like USB 3 or something?
I think they're probably all USB 3. Yeah. Yeah. Yep,
Yeah,
and
sure. Probably with high definition and stuff like that, and maybe try out with a brand spanking new computer. Would you be better off with that?
Yeah, the image format doesn't matter much. So having like a high resolution CCD camera isn't really going to help much. Because all telescopes on the ground are limited by atmospheric seeing, right? And typical seeing, good seeing, is about 1 arc second or so, right? And so, even if you have pixels that are, 1/10 of an arc second in size, you're not going to make any kind of improvements to the images at all.
So even if you want that can do 1080p, it still doesn't matter, right?
Doesn't matter much in terms of what I'm doing. No, not really. Not really. But yeah, I mean, at some point, I'll definitely get all new gear and all that. But at the moment, this seems to be looking pretty good. So I'm
yeah. If you would have a budget for your new equipment, what would it be, and what and why?
Question that, actually.
Yeah, that is a good one, and I haven't really looked into that much. As you can see, I'm sort of competing for screen time here. She has decided to just stare at the screen. Hello. So I think yeah, to answer your question, Bobby, I really haven't. Hello there. Cool. I want to see that.
My fatty friend.
There we go.
Go on, I'll put you back.
And when it's time for my dog to go to bed, he really does still go to bed.
Yeah, that's cool.
He's just sleeping alone, just being nice.
Yeah.
He might have his legs up, like something like he was like a dead dog or something, but that's about it.
That's great. But yeah, I think, I haven't really looked into new equipment at all because, frankly, I'm pretty satisfied with what I've got. The only thing that I would like to change, and I can't at all with the setup I've got, is the image download time. Right? It takes almost 15 seconds to grab one image, and with USB, that would be less than a second, right? So that's sort of my only gripe with the parallel port, right? Is that it's really, really, really slow. But I'm not complaining much because the quality of the data looks pretty good. I'm um, the accuracy that I'm seeing is somewhere between 20 and 60 millimagnitudes, which is really, really, really good. And the precision is somewhere around there too. So that's not bad. It is definitely good enough to do science, right? And that's sort of my thing. Yeah, really my only gripe is the download time. But I think, to put it in sort of ballpark terms, I think if I had, well, let's see, a really, really, really good CCD camera these days is probably going to run somewhere around like 10K or so. And then a new computer, I don't know, a couple K. So somewhere in that ballpark or so.
So you said the CCD will be about 1,000, a new computer will be about $2.
10. 10.
10,000 for a new.
Mm-hmm. For a good one. Yeah. Yep.
That's cash.
That's a little bit. See this thing right there? That's where I put all my change. So that's my savings account for the new CCD camera. See, it's not very full either.
I think you'd be better off if you was accepting donations, would be a PayPal and stuff.
Yeah.
Bobby secretly won the lottery, and he won't tell anybody. But just tell him you need a cool million.
That's it. That's all. Yeah. No, I don't worry about those kinds of things as long as I've got stuff that works, and the quality is pretty good. So I really have no complaints, and this is the first time actually that I've ever observed this kind of object before.
So let me ask you this: if the technology that you have still works like a charm, what if you were up to find a parallel to USB cable or some type of adapter to convert it from parallel to USB?
It's not going to speed it up though.
I know, but do you think it'd be possible for a new computer, or do you think the software won't support it?
Yeah, that I don't think that would be a problem at all. Yeah, I definitely be able to put a new computer on it, and I've got a computer here to do that. So yeah, I just I put this together and
you just need to get like a special cable called a parallel to USB, or some kind of adapter that will make it work and stuff. And Because like Jill's, he's got a USB to serial for his ICOM radio, and every once in a while he does his satellite tracking on it.
Mm-hmm. Yeah, yeah. That's not going to improve anything. So so why do it? You know, I mean, what I've got works. So yeah, you know, my attitude is that if it ain't broken, don't try to fix it, because it works. You know, this system is actually working as well as it possibly can, right? The only way, you know, to make improvements is really to change the whole thing, get a whole new system, right? Which is you know, that is definitely, you know, part of the plan, right? But what I've got now is great, is absolutely great. So I have absolutely no complaints at all, especially when I see data like that.
You have like zero interest in astrophotography. You're just like a regular data collector.
I just want to count photons. Yeah. Well, and you know, do the science that follows after that too, right? You know, because so, you know, once I'm satisfied with this data, right? Then I'm going to go into modeling it and trying to understand, you know, what this system is actually doing, right? Because I'll be able to take this data.
Now, can be converted into sound or something, or no?
The what?
Can that also be converted into some form of sound or something, or no?
Sure. Yeah. You can convert anything into sound.
I know you love to make. I know that you love to make art in sound with only just data.
Right.
That's cool.
Yeah. I would definitely be able to do that. In fact, I could take that curve and use that as a waveform, right? Turn it into a waveform and see what that sounds like. So yeah, there's lots of possibilities there. Yeah, definitely. All right, cool. I'm gonna check the chat really quick, and then so Ingrid is there.
Yes.
Tom is there. Tim is there. Uncle Bill is there. Cool. All right. Very, very cool. All right. Well, went a little bit too long on that. I definitely want to get back into the constellation of Leo, because we were just starting to dive into Leo last time. And I wanted to get back into it if I can find my, there it is. All right, so let's do that. I'm going to get rid of that. Let's go over here. We can use that as, so I guess probably what I should do is start again with Burnham's and see what they have to say about interesting things in Leo. So here's the famous Burnham's Volume 2.
Now, if that was a sneeze this time, I think you got yourself a 6.
I don't think that was a sneeze. Don't think it was. Don't think so. So let's see if there's any interesting binary stars. I know, I think, isn't Regulus itself? Isn't Regulus a binary star? I don't remember. Yeah. Regulus, the brightest star in the constellation of Leo, is a binary star, and in fact, the companion star to Regulus is, I think, also a binary star. So it's kind of a double of sorts. So that's kind of cool. See if we can see anything about that, I can go to Burnham's description of Regulus here and see if it says anything necessarily about that. So, yeah, so it's saying, the small companion star to Regulus is actually easy to see in a small telescope. Let's see, were they saying what the separation is? I think it's at 177 arc seconds. So that's pretty far away, right? That's almost 3 arc minutes. Arc minutes away. Regulus itself is magnitude 1.5, and its companion is magnitude 8, right? So that's absolutely, yeah. So that's absolutely true with a small scope. Even a pair of pretty decent binoculars. You might be able to see that. Definitely with a good scope, you'd be able to see that. No problem. And at least according to Burnham's, right, both of those stars do have the same proper motion, which means they're moving in the sky in the same way, which means that they probably are true companions. Pretty cool. But yeah, they've got to be physically very, very, very far apart. I don't think it says anything about that here, at least. But then, as I said, the 8th magnitude companion is actually a binary star too. And at least according to the listing here, let's go back. So the companion to Regulus is 8th magnitude, and its companion is 13th magnitude, right? So really, really, really faint, with a separation of only 2.6 arc seconds. So really, really, really close to each other.
Do any of these in Leo have an orbiting body around them?
Are you talking about like a planet?
Or a moon?
I know that Wikipedia says that there are 13 stars in Leo that have confirmed planets. I don't know if Regulus is one of them or not. I have my doubts, mainly because Regulus is so bright that the telescopes that look for these kinds of things
Pick out something as low light comparison.
Well, they wouldn't be able to see it because Regulus is so bright, it just washes everything out, right? I mean, it completely blasts the camera, right? Total way over exposure. So they're not actually able to see anything that bright, right? So yeah, I'm not even sure, if someone has even looked at that yet. So that might be an interesting thing to actually look into, and see if Regulus, might have some kind of transiting planet. It might. I don't know if anybody's looked. Definitely don't. Let's see what else they say about that companion. Magnitude 8 and 13. So yeah, and it looks like, at least according to Burnham's, that the separation has decreased from 3.9 arc seconds separation to 2.6 in a little over 100 years. So that's a pretty good orbit. Let's see if there's anything else here. I guess there might even be a fourth star too. But yeah, at least according to Burnham's, there's nothing definitive about that. So we can probably what we should do. Why don't we just dive right into Regulus here and see. Let's see. So I'm going to share my screen again. And go over here. Go to infinity. And we'll go over here and let's see if there's anything else. So Regulus itself, well, we can just punch on the Wikipedia page here. 79 light years from the sun. Pretty bright. So at least according to this, it has a magnitude 1.35. Cool. And its companion is 8.1. And then that guy's companion is saying now that its magnitude is 13.5. And Regulus itself is a spectroscopic binary, which means that it also has another companion. It's just so close, that we can't actually see it visually, right? But when we look at the spectra of Regulus, we notice that it changes. And at least one explanation for why that might be is a very, very close-in companion of some sort. But I can zoom in here a little bit. So cool. So yeah, it's not saying anything about Regulus having any detected planets, at least not yet. But it's complicated anyway, right? At least 4 stars. So I mean, it's when does it become a cluster, right? Does 4 stars make it a cluster of stars? I don't know. Not quite sure about that. Okay, cool. So yeah, it looks like the spectroscopic binary star might be a white dwarf star. That's kind of cool. 40 days to complete a common orbit. That's pretty fast, right? It's takes Mercury about 88 days to go around the sun once. So this is about twice as fast as that. So that's pretty amazing. It's hard to imagine what that looks like, right? This white dwarf star zipping around Regulus, right? I think Regulus is a pretty big star. Yeah. So it's 4 times the mass of the sun and about 3 times the radius. But much brighter. It's almost 300 times brighter than the sun, right? And that's because of its spectral type, which is a B star, right? B stars are big, hot, bright stars. The spectral types are what? O, B, A, F, G, K, and M, right? And our sun is a G star. It's a G, I think it's a G2. It's either a G2 or a G5. So, you know, our sun is considered a yellow dwarf star, but this is a B8, which is a big boy. Big boy. Yeah.
Indeed.
So really bright, really big. So yeah, and hot, right? 12,460 degrees Kelvin surface temperature, right? Our sun, I think, is around 6,000 K or 5,000 K. So yeah, and relatively young, right? I mean, our sun, again, you know, at least according, you know, to the latest story, is about 5 billion years old. And Regulus, they say, is, you know, maybe a little bit more than 1 billion years. So, I mean, definitely not a young star, but definitely not as old as our sun either. So that's pretty cool. That's pretty cool.
Right, guys, I hope you'll pardon me. I need to hit blanket market.
Sounds good, Tim. Thanks
I'm
for
on the
coming
road
in.
for 2 hours, so thank you very much, Matt, and goodbye to everybody, and hope you're all well and stay well.
Yeah, excellent. Well, travel well. Travel safely.
I'll do
Good
my
night,
best.
Tim.
Good night, everybody. God bless.
All right, take care.
All right.
Bye. All right, well, cool. And yeah, you know, because it's so bright. Where is the? Do we have a absolute magnitude here? We've got an apparent magnitude. I thought I saw. I guess this is the absolute magnitude. Yeah, that would make sense, right? So the absolute magnitude is the apparent magnitude if the star was 10 parsecs away, right? So the fact that this guy is 79 light years away, which is, pulling out my handy dandy calculator here, divided by 3.26 is 24 parsecs away, right? So but if it was 10 parsecs away, then it would have an apparent magnitude of negative 0.57. As it is, it has an apparent magnitude of 1.4, right? So yeah, that makes sense. Definitely makes sense. Very cool. Very cool. Rotational velocity. Yeah, I don't know what the rotational velocity of the sun is. I don't know if this is fast or not. 347 kilometers per second. That seems fast. That seems, yeah, that seems really fast, right? Because that's 347 times 3600. So that's 250,000 kilometers per hour, right? So yeah, I guess that's pretty fast. Pretty fast. Let's see. So here's just you know, the other information about the companions. Bunch of different names, of course. Cool. Oh yeah, we got a Sinbad reference too. Of course we do. Let's see, what else do we have here? Regulus B, Regulus C. That's about it. And Regulus, of course, is being relatively bright. I'm sure has been well studied. I wonder if we can find like a spectrum, a visible light spectrum of Regulus. I wonder if something like that exists.
Maybe if Sinbad may have some information, that'll be better.
Yep, could very well could be. But it's almost going to be information overload. But let's do it. That's what Astronomy Daily Live is all about, information overload.
That's it.
Oh, interesting. Yeah, they're calling it a high proper motion star. Yeah, in right ascension. Wow, it is moving fast too. Didn't realize that. Let's see, because this is negative, right? That means that it's moving towards lower and lower right ascensions, or it's moving west, right? So it looks like it's moving almost due west, right? At 248 milliarc seconds per year, which, I mean, relatively speaking, is still really small, right? That's what, one quarter of an arc second per year. So with my system, for example, right, I would have to wait about 4 or 5 or 6 years in order to really be able to detect its motion. But yeah, kind of interesting. I didn't realize that it was quite that fast, but that is zipping pretty fast. Look at all those names. Wow. So quite a few. Just different catalogs, as I said. I mean, and this sort of confirms what I thought, that this is probably a very much studied object. I mean, it is quite bright, so under certain circumstances, it's kind of easy to see. Although, as I also said, it is bright enough that it's sort of going to blow out a lot of systems. They're not going to be able to look at it because it's just too bright. So yeah, lots of references. 789.
No time to look at them all.
No time to look at them all, for sure. But maybe we should look at the first one. The first one ever made. At least going back to 1850, right?
Prepare for the torture.
Let's see what the first one is here. 1892. Potsdam observations of motion in the line of sight. Cool. I wonder what that's all about. Let's see if we can even see it. Ooh, we can. Let's see what this. So this is from 1892. So what? This is 127 years ago. Special importance for contains the details of the spectrographic determinations of the motions of stars in the line of sight, which have been so successfully carried out during the past 3 years at the above observatory. So spectrographic determinations of the motions of the stars in line of sight. I think what they're talking about there is what we would now call radial velocity, right? Measuring the motion of these objects either as they move towards us or go away from us. And you do that spectrographically, as they say here. Sufficient harvest from 3 years' work, even if they stood alone. Recognition of the orbital motion of algal and that of spica. Let's see, can we actually search for, this might be too old to, yeah, it isn't actually in a text form. It's just sort of in a photographic form. So we'll have to sort of scan this by eye and see if I didn't really see how many pages there are.
I saw 6.
Oh, 6? Okay. So there's another mention of spica. Remaining 27, all 3 observatories agree as to the direction of motion in 12 case. Here we go. So here's some listings. Stars for which the 3 observatories are in agreement. And where is, well, there's Gamma Leonis. Here is Regulus. So stars for which Dr. Huggins stands alone. So yeah, kind of interesting. See, they're making some kind of a measurement and it like completely conflicts with these other observers. Suggest systematic differences between the different observers. So who knows who's right, you know? A Greenwich star showing progressive change. I'm not quite sure what progressive change means. And in fact, I'm not quite sure what these numbers mean. Maybe we should try to find that out first. Observing common, the motions are expressed in German geographical miles per second. Okay, so this is in miles per second. Cool. So if it's a plus, that means that they're moving towards us. And if it's a negative, it is moving away. Maybe it's the other way around. Yeah, I'd have to think about that. Regardless, at least we know what these numbers mean now. So 3.2 miles per second, right? And we have an actual radial velocity measurement now of 5.9 kilometers per second. Wow, that's actually really, really close, right? 3.2.
Let's see the most recent one if we can.
What's that?
The most recent one. Let's see that.
Okay, yeah. So 3.2 miles per second. If I multiply that by 1.6, 3.2 times 1.6 is 5.12 kilometers per second. And this is saying 5.9. So, wow, that's pretty good, right? It's pretty good for 127 years ago. That's very much in agreement with today's modern measurements. That's pretty cool. 3.2, yeah. So yeah, a little bit of inconsistency here, right? So, but as you can see, they're looking at just at just the brightest stars, right? Sirius, Castor, Procyon, Capella, Altair, Vega. But yeah, I mean, that's probably about as good as they could do anyway. So, okay, I think that's the end of it. Yeah. Cool. So yeah, I don't think that there was a, well, I don't think that there was a, another paper until 1910. So yeah, quite a few years later. And then, you know, it just goes on and on from there. So yeah, let's sort of look at the latest and greatest spots. The search for planets orbiting 2 stars. There we go. Let's see if one of those is Regulus. I don't know. Why would this paper be mentioned if Regulus wasn't mentioned? Who knows? Sometimes I wonder about that. These papers are referenced under these headings, and then there's no mention of the actual target. Wow, so this looks like a pretty big paper. It's taking a long time to load. It's going to give me a chance to finish up my mug of hydrogen hydroxide here.
Probably a good time to review it as well.
Well, we must be near the end. We must be near the end of the live stream then, because now I am out. And that is a crisis. Definitely a crisis. All right, let's just do a simple search.
Oh, just always just one entry?
One of 3.
One of 3.
One of 3. So, all right, I've got to rotate this.
Yeah, I'm sorry. I don't think I can rotate my head when you get a crypt neck.
Well, you just have to practice. All right, let's see what all this is here. Okay, so Regulus was actually one of the targets of spots. I've never heard of spots, but we should look into that a little bit. So here's just, you know, some basic information, right? Position, distance, age. So this is actually saying 600 million years. Wikipedia was saying about 1 billion years. So there's a little bit of a discrepancy there. And this is saying a B7 as opposed to a B8. That's all right. 3.4 times the mass of the sun.
If you look at the top of about where it says age, it says millions of years.
Right. 600 million years. Yeah. And Wikipedia said about 1 billion. So that is quite a bit off. Quite a bit off by a factor of 2 almost. Let's see. Right. So the orbital period of the companion, 40 days. Eccentricity, they've measured to be 0, which means pretty much circular. And it looks like, I'm not quite sure what this last thing is, but it sort of looks like it's how close the white dwarf actually gets to Regulus, and it says 0.67 astronomical units. So that's I think Mercury's around 0.4, 0.3 or 0.4, if I remember right. So anyway, so that's sort of the basic info. Let's look for the next entry with Regulus. Okay, see spots 2. I'm going to have to rotate this back around, it looks like. There we go. Where'd it go? There it is. So I'm not quite sure what this is talking about here. It looks like they're just... Okay. Oh, all right. So it's just some notes on the individual targets. So they're talking about Regulus here being a quadruple system, and it says see spots 2. See spots 2. What is this? This is spots 3. Okay, so we need to actually go back. But there's one more mention of Regulus here, so let's see what that is. Spots observation log. Okay, so this is just noting the fact that it was observed on the 20th of January 2016 for 14.3 minutes. Okay. But yeah, I guess we probably have to go back to spots 2, which maybe that's not going to be too painful. I don't even know what spots is. Okay, it's the search for planets orbiting 2 stars. That's kind of an unusual survey, right? I guess the other way to say that, right, is looking for planets that are going around binary stars. Pretty interesting. Let's see if we can find a spots 2 really quick like. See, because this is spots 3. At least that's how I'm interpreting this. Could be completely wrong. Spots. We're gonna find it.
Do you think the year will give you a clue of where spots 2 is at?
Yeah, I could do a search too. Probably wouldn't be too painful. Here we go. Spots 2. Here we go, right there. Let's see if Regulus is mentioned. And even if it is, we're running a little bit long on the live stream. Don't want to take up too much more time. We've got all the time in the world, to look at all this stuff. So I don't like to rush it if we don't have to. And we definitely don't have to. Let's see if Regulus is mentioned. Oh, it is.
No, they always say never say never.
Never say never. 3 cases of post-common envelope systems in our sample. The detection limits were derived for the original system age. Okay, so I'm not really... Post-common envelope were performed. Okay, cool. Everybody's really, really excited about finding planets around other stars. I'm not so excited. I mean, I think it's cool and all that, but I don't really know what all the excitement's about. Not surprised that there are planets being found. I think it's great, but yeah, it seems to be that there is maybe a little bit too much excitement about that. I don't know. Maybe it's just me. Let's see what this says up here. Yeah, we'll have to look into spots a little bit more. That's kind of cool. It looks like it's well, at least a European endeavor. Pretty well represented over there. UK, Italy, Switzerland, Sweden, France. Sweet. So a large number of direct imaging surveys for exoplanets have been performed in recent years, yielding the first directly imaged planets and providing constraints on the prevalence and distribution of wide planetary systems. However, like most of the radio velocity ones, these surveys generally focus on single stars. Hence, binaries and higher order multiples have not been studied to the same level of scrutiny. Cool. Okay. So they're using the VLT, which is the Very Large Telescope. Derive the expectant values and frequencies of companions. Huh. Yeah, I'll have to look at this a little more carefully. This, of course, is a big paper, right? I mean, it's so big, they have divided it into pieces. So yeah, I'm not even going to try to get through much of this.
Got a bit super late for you. We're about the whole way, James Dugan.
Hey there, James Dugan. Yeah, we're almost on our way out here. We're just starting to scratch the surface on Leo, and we sort of got stuck on Regulus here, and pretty amazing. Pretty amazing. I'll definitely want to look at this a little bit more. Look at all these references. Wow. Holy schmoly. That's a lot of references. Incredible. But, of course, this research has made use of the Simbad database. You betcha. Best one there is, as far as I'm concerned. Kind of nice. Kind of nice, yeah. I'd like to look into this a little bit more. I will definitely try over the next day or so to look at this a little bit more, look into spots a little bit more, see if we can learn a little bit more about it, you know, its techniques and all of that, because this looks like, you know, they're talking about, you know, the actual data, and I'd like to see how they actually, you know, collected this data. Yeah, kind of cool. A lot of that might be covered in at least partly in the introduction here, but yeah, I think what I'll do is I will post a link to this paper over on the Discord server. I'll do that right now so I don't forget, and then I'll try to take a look at it over the next couple of days. And I greatly encourage everyone, you know, to take a look at these things, even if they fly way over your head. That's okay. Don't worry about that, right? Look for some things, you know, that you might be able to understand, and go from there. Don't sweat it. You know, most people aren't going to understand this stuff. So, but get what you can out of it. It's kind of an interesting thing, right? I don't think that I've ever heard of anyone searching for planets around binary stars before. So that's kind of a novel idea. I like it. I like it. All right. Well, it is definitely way past time, so I'm going to get out of here for now. But I will definitely be back tomorrow for sure. So let me check the chat one more time really quick. And all right, cool. Yeah, I'm definitely going to get out of here for now. So take care, everybody. Have a great evening, a great day. Make sure to subscribe if you haven't. Hit the thumbs up if you so desire, and share this around. We're just you know, sitting around here, just having a blast, thinking and talking all things astronomy. You never really know where things are going to go, or what things we're going to look at. I just sort of follow my nose and try to listen to all of you, to see if you want to steer this in any particular way. But for the most part, I like to follow my nose and see where it leads. And this is kind of an interesting thing. This thing called spots. So yeah, I think I want to look into that a little bit more over the next day, and see what those folks are up to, because it seems pretty interesting. Yeah, kind of interesting. All right, well, take care, everybody. I will see you in about 22 and a half hours. All right, take care. Peace, cheers, and all that. I will see you later. Bye.
Live long and prosper.
Yes, sir.